So for part C, it says we should calculate the total heat energy required to convert 5 kg of water, initially at 30 degrees, to dry saturated steam at 5.5 bar. Take specific heat of water as 4.187 kJ per kilogram degree Celsius. Now we know that the total heat, QT, given the time to be QT, is equals to what? The sensible heat plus what? The latent heat. Like I explained earlier, that the sensible heat is the heat that due to addition and removal of it tends to increase or decrease, brings about change in temperature, right? Now the latent heat is the heat that is needed by a liquid to move from liquid state into vapor state, right? So now we know very well that my Q S essentially is equals to what? MC change in what? T, where the M is the mass, C is the specific heat capacity of what? Water, and this is change in T. Now we know that my change in T will be what? The T saturation minus what? The T. The saturated temperature minus what? The temperature. Are we good? So from here, I can now say that my QS will give me M. I will now say my QX will give me, my QX will give me MC into bracket what? TS minus what? T. So if I substitute in this value wherever I see QS and I place this, my QT will give me MC into bracket TS minus T plus what? Now what is QL? QL, latent heat, is equal to what? The mass times what? The enthalpy. Is that taken? So it will be what? M times what? HFG. Because we're talking about water here now. It has not yet moved into vapor, so we're using HFG here. Are we good? So from here, we'll move further. We will now say, let's now see what we have now. So we have the mass to be equals to what? 5 kg. Initially, the temperature, the normal temperature of it, T, is given as what? 30 degrees Celsius. Now, for you to get saturated temperature, you get it from what? The saturated pressure. Now, our saturated pressure, PS, is equals to what? 5.5 bar, right? So to get saturated temperature, you look at the TS now, will be what? PS at, it will be, your PX will be TS from here, sorry. So to get the saturation temperature TS, it will be TS at what? At 5.5 bar. So you check it on your steam table. So if you check it, this is the pressure. I will go and look for 5.5 bar, and this is my 5.5 bar here, and I'll look at the TS here. What's the TS? 155.5 degrees Celsius, right? So that will give me 155.5 degrees Celsius. That's the TS. So I'm going to substitute all this value, and also I need to know what my HFG is. So my HFG at 5.5 bar, my HFG will be, so you go and check your enthalpy at 5.5 bar. So this is the enthalpy at 5.5 bar here. So we have 5.5 bar here. I'm moving towards my HFV. So look at it here, HFG, right? So HFG, I'm going to trace it down to where my 5.5 bar is. and this is the 5.5 bar here. This are all good, and that is 2097. So I'm having 2097 kilojoule per watt kilogram. So we'll now substitute all our value into this equation here to get our total temperature. So if I substitute here, my QT will now give me the mass. We know the mass is 5 kilogram. That will be 5 times the specific heat capacity of water, which is 4.187. So we have times 4.187 into brackets the TS, which is 155.5, minus the T, which is what, 30. We close the bracket now, plus the mass here is 5 kilogram into bracket the enthalpy, which is 2097. This is 2097. We'll have 2097. So this will now give me, if you multiply, at the end of the day, you're going to be having this. We have 4.187 times 5. 4.187 times 5, and that will give me 20.935. 20.935 into brackets 155.5 minus 30. 155.5 minus 30, and that will give me 125.5. 125.5 plus 5 times 297. We have 5 times 297, and that will give me 10,485. We have 10,485. So the QT here will give me 20.935. 20.935 multiplied by 125.5, and that will give me 26.734 plus 10,485. So the QT here will give me plus 10,485. So we have 13,112.34 kilojoule. So that will be my answer. That is the total heat in the system.